Okay, let us begin. So till now we have studied we have studied linear algebra and probability. And today, as I was saying, we'll be linking both of them. We'll be learning things that actually link both of them. So let's start without much ado. So I'll give you a basic few. These are oceans in itself, but I'll just give you a brief idea of what is called a convex sets are. But we'll be mainly dealing with convex functions instead of convex sets, right? So a convex set is a set. Convex set is such that, so if you have a set, roughly speaking, line joining any two points in the set will be in the set itself, right? So from section formula, do you remember? So if this is x, this is y, and you divide by theta and 1 minus theta. So what is this point that you will get? You will get it as, right?
X theta plus y into x
Yes,
into 1 minus theta plus y theta.
correct. So let me write theta the other way, but it should be this, right? So 1 minus theta, because more the, so if you have larger theta, which would mean that uh, this point would be, let's see. So you will have theta x plus 1 minus theta into y, right? So what will be this point? So if you have half comma half, you have it in this point. And if you the further you add theta, the higher your theta is. So theta will be between 0 and 1. So if tell me if theta is equal to 1, where will be the point?
On X.
On x. So do you see this is like the center of mass concept, right? So if you have a theta, the larger the theta is, you will be moving towards x, right? There's no doubt regarding that, right? So the weightage you'll be giving to that point will be much higher compared to the other points. Okay. So why did I say this? Because to make you understand that theta x plus 1 minus theta y would belong to the set C, if and only if x comma y belongs to C, right? If x comma y belongs to C, theta x plus 1 minus convex, these are called convex combination. What are these called? Convex combination would belong to the set C. Okay.
But
So the
theta will
line join.
be on the other side, right?
Okay, you're saying theta, it should be on the other side, but I'm thinking if it is right, true. Theta should be on this side. So if you are geometrically thinking that way, so then that is true. So theta, if it is 1, then correct. So in terms of what is it called? In terms of the section formula, this is true, correct. Because you will be taking theta time that if you take the distance between these two. But I'm just telling why did I write theta that side? Because I was taking combinations with the theta. And I was thinking of theta more as the weight towards x instead of the length, right? So for example, if you have a larger weight, a larger mass on x, you would have the center of mass towards x, right? So I was thinking more of this on that terms, but in mathematically speaking, yes, you're right. So good. So line joining belongs to the set. So why did I say this? Because today you'll see when you do optimization courses and all. So do you agree that your norm balls, you look at the pictures, they are all convex sets, right? So we saw norm balls last time. And are they convex sets or not? They're convex sets, right? So you see any 2 points on the norm ball, you're going to get a point inside. Can you tell me a proof of that? Very simple proof is there. Instead of mathematics showing it this way, if you recall the concept, theta x plus 1 minus theta y, how will I show that this belongs to this set itself? Can you tell me? So I am telling mod norm of x is less than 1 and norm of y is less than 1, right? I'm telling you this thing. So how can I show this? If you have recall from the last class, very simple, right? What property
We
will I
can
use?
use inequality.
Very good, triangle inequality, right?
Yes.
So you will get a mod of theta times. So theta is a positive number, so you don't need to put a norm over here. So you'll get this, and you'll get y. And please do the assignment. I have given my heart and soul to formulate the assignment so that you learn everything that is there. So it will be an augmentation to the amount of work that we have put in the sessions. So that will give augmenting your understanding based on the concept that we have learned. It's not exactly what we have learned in the sessions, but it is using the concepts, applications of them. So theta x and 1 minus theta y, right? And so these two terms are the sum of these two terms would be, do you agree? So this is less than 1, yes or no? And this is also less than 1, right? Yes or no? Correct?
Yes.
So I'll put an upper bound, and what will I get? Theta plus 1 minus theta, which is equal to 1, right? And therefore, theta x plus 1 minus theta y would belong to the norm ball, right? Correct? Do you agree? Everyone?
Yes.
Yes. Good. So similarly, you can have non-convex sets which are difficult to optimize over. Why am I saying this? Because eventually, learning machine learning starts only when you have understood optimization. And we are not going to do optimizations here, but I'll giving you the foundational mathematics for learning optimization. So what is this? So it's not a convex set because the linear combination of, or convex combination to be exact, because linear combination can be anything. So convex combination is a special case of linear combination, right? So the sum of the alpha should be equal to 1. Remember that. Has points outside, right? So I want you to tell me, why are these sets bad? We'll see in optimization, these sets are bad because doing things like gradient descent and other algorithms would take you out of the set. So if you take a convex combination and you say you have a constraint over which you want to optimize, say you have a function minimize over f such that x is belonging to a set, right? And most algorithms, what would they do? They would take a point and they would run 2 points, maybe take a linear combination and so on. Do you agree if this is not convex, if it is not convex in some way, these 2 points, if you take a convex combination, it's sorry, forgive my picture. So if it is not convex, if you go in this direction, say, you may fall outside the set, right? Which is never possible in a convex set. Convex set, you would, if you take linear combinations of these 2 points, you would eventually lie within the set, right? So it will become difficult. You need to have projections to learn these sort of optimizations, right? So we'll be dealing with these constraints today. In case of like unconstrained optimization, it's just a convex set because it's over Rn, right? Rn, everything will be in the set. In case you want any clarification, you tell me. Or is the concept of convex sets clear? So convex sets would be convex combination is a linear combination with summation of alpha I equal to 1. Do you agree? So it's sort of a expected value sort of a thing is how you learn this, right? The expected value of the score and so on. Anyways, so let's see what is convex functions are. So this is what will be mainly the center of today's discussion. So the idea of convex functions comes from the idea of convex sets itself. That's why I introduced the set. So convex function would be f of theta plus 1 minus y, theta x into 1 minus theta y would be the function itself multiplied by the scaling factors and other parameter, other variable with the other scaling factor, right? This is very simple. So it's a linear combination with a convex combination of the points. So it's like, what do I mean? Look at this figure. So if you have 2 points on the domain of the function, right? So when you take a convex combination of those 2 points, you'll get somewhere here, yes or no? Right? Again, I have written theta here, so I'll write theta here and 1 minus theta over here, as Saptoshi told me. So, right? Isn't it? Do you
Yes.
agree? So you will have a point like this. But do you agree that this is one x and this is one y, and you're going to change this is your say your z, right? Do you also agree that the function value at z will be lesser than the line joining them, right? Yes or no? The function value at z will be lesser than, so the function value of z will be less than what? Tell me.
Theta fx plus 1 minus theta fy.
Correct. So it would be following under this. So this is also known as it is also if you form a epigraph, that is area over the curve, it will form a convex set, right? This is called an epigraph. Everything above the curve, right? So is that a convex set? This is the relation between a convex function and a convex set. The epigraph is a convex set, right? Do you agree? Theta and this will all lie above, right? So how will you define? So if you have understood all my sessions till now, I have whatever we say in English, we try to write in terms of maths. So what would be epigraph of f? Tell me. How will I write it to explain that it is above the curve? Very simple, tell me. I'm just wanting you to learn to write it. So do you agree this will be y such that y greater than f of x for all x belonging to real? Right? These are all the points, isn't it? Or is there anything else you want to tell me? Is this right or wrong?
Sir, how is y greater than fx?
Exactly, this is wrong. I wanted to ask you, what else would I do? I would do x comma y, right? Now is this all right? These are all these points, not only y. So this point, is y f of y, is y greater than, here you have an x comma y, right? Is y greater than f of x or not? This is why I was trying to see if you
Hmm.
if you're paying
Yes.
attention or not. Right? At this point is above, right? F of x naught is, oh, you're saying, right only, no? F of x naught is less than y naught, right? In this point, is it okay or not?
Yes. Yes.
Correct. So can you tell me why is it so? What is the relation now you are getting? So your convex function will form a convex epigraph, right? Your convex function forms a convex epigraph. So why did I introduce convex sets? Because this is how initially convex functions were defined. So you define a set, that set must be convex, right? So how will you prove it? It's very simple, right? Can you tell me? Take any 2 points such that x is, your y is greater than f of x naught, right? Yeah. So let's take 2 points. P1
It will fall
is
inside the convex area, right?
very good. Your point 2 I will take is say x1 comma y1, right? Very good. So what would be my x tilde theta x naught plus theta times x1? Do you agree? 1 minus theta times x1. Correct. So f of theta times x naught plus 1 minus theta times x1, right? By definition, if this is greater than theta times f of x naught plus 1 minus theta times f of x1, right? What does it mean? This is your y0 and this is your y0, right? y1? Yes or no? F of x naught is y.
Yes.
So if this is true, so do you agree? So if this is y0 and y1, so do you see that this is greater than equal to y0 plus 1 minus theta y1? This is greater than equal to this any z, right? If this is greater than equal to that, do you also agree that these points, whichever you have over here, these points that you are forming over here would belong, are indeed satisfying this property, right? F of x, right? This is the f of x. Do you agree? Where theta x naught plus 1 minus theta x1 is, comma, your, what are the y points on this line? F of theta x naught plus 1 minus theta x1. For all of these, what will I have? I will have this parameter, whatever you have over here, would be greater than, would hold for the epigraph of x. That's what I'm saying, right? Let's not write this complicated thing. Let me show you. So if this is true, I mean your x comma y lies above the curve. That's what I mean, right? Right? Anything in which you will have this will lie above the curve, right? Yes or no? Since this is true, where the curve is below. Do you understand? If you have not, tell me.
Yes.
Yeah. So your x tilde will be less than f of x naught or y naught plus 1 minus theta y1. Very good. So that will form a, this will give you a convex set over which you'll be forming a convex function. For that, you need this condition to hold, right? Then only your epigraph will be convex. Is this clear? Good. Now flipped inequality will be concave. So do you also agree? If I have a curve like this, I will have my theta x plus 1 minus theta y will be greater than theta fx. So in your GANs and VAEs, this is used extensively, right? Yes or no?
Yes.
This would be your opposite trend that you all have. Very good. So if we have understood this, can you like formalize the proof that we have written? So how do I formalize this proof? I was like without graphically doing it, I want to show that the linear combination of theta p1 plus 1 minus theta p2 will belong to the set. You have to show it belongs to a set. How will you show that? The graph we have seen. Graph, yes. Any idea of how to do it mathematically without using the graph? So here, if P1 belongs to C, what can you write? I just wanted to see if we can use the problem. Like I don't want to just leave it on the graph since we are doing everything mathematically. If P1 belongs to C, what will happen? Tell me.
The P1.
Not
What
bad.
is P1?
P1 is this point, right? Yeah, of course.
Oh.
P1, because this set is defined over points, right? Points above the curve, isn't it? It is bounded by the bowl. It's like a liquid put in the bowl, right? Isn't it? It's like that liquid. So do you agree P1 belongs to the set means f of x naught will be less than y naught? Right or wrong? Correct?
Yes, yes.
This is how you define for sets, because today I'll just give you the flavor. So I'll not be able to show you for sets. So I never thought that I'll do it today in the class, but I'm doing it anyways, so that you know how to do it for sets. Yes or no? From the definition of the set, because these 2 points, P2 belongs to the set. As it belongs to the set, your f of x is less than the y value, right or wrong? Is it clear?
Correct. Yes.
Now I will say multiply theta on both sides, right? If I multiply theta, these are all positive numbers. Is it okay? Correct? Yes or no?
Yes.
Good. So what will I end up having? I'll be ending up with f of x naught plus 1 minus f of x1 less than equal to theta of y naught plus 1 minus theta of y1. Now I have to show what? Now here you do not have any x, right? You only have y's. These are only y's, right? There's nothing other than y in this case. Yes or no?
Yes.
So you have to show f of x will be lesser than that, right? Yes or no? You can come up with you can tell me. So if I define from the definition of the convex set, from definition of convex function, right? We can say this is less than f of theta of x naught plus 1 minus theta times x1. Yes or no? This is how we have defined it. Are you happy?
Yes, yes.
Very good. So now you see all these points that are z over x, and these are all z over y, right? These are some y. Let's write it as x tilde and y tilde, right? Do you see x tilde is less than f of x tilde is less than y tilde? Yes or no? Do you agree? Therefore, x tilde comma y tilde belongs to the epigraph. Yes or no? See, I did not have the proof in mind to do it, but if your concept is clear, you can do these proofs like this. I never thought I'll do it in class. Is it okay? Did you understand?
Yes. Yes, yes.
Others? So this is how you should think about it. So when you have sets, you have to show that the combinations are in the set. When you have functions, it's much simpler process. So now from now we'll do only on functions. Let's do it. This question, since you have understood on sets, please tell me how to do this. So you have to show that a max of y, a coordinate, say x is a vector from 1 to n, all the elements, so it's an infinity norm, is a convex function. How will I show it? So what is the thing that I need to show? This will require a very short space. So that's why it's easy proof. That's why I'm asking you. So theta x plus 1 minus theta y will be less than equal to theta times f of x plus 1 minus theta times f of y. Yes or no? Correct?
Yes.
This is what I have to show. To show that it is a convex function. So now tell me. So x comma y say are belonging to some real numbers or to some Rn. So what would be theta x plus 1 minus theta y? Please, others. If you do not interact, you will fall asleep and you will leave. That's why I'm telling you to interact. So this is a new step, new point, right? So which will give me max of x1 theta times x1 plus 1 minus theta times x2 comma theta times what am I writing? Y1. Yes or no? Correct. This is the max over we'll get. If x and y are sets in Rn, we are just adding linear combination. Correct? Theta x plus 1 minus theta y, what will it be? This will be this vector, yes. Understood?
Yes.
Okay. So do you agree that now this you have to show is less than theta times max of x1, x2 dot xn plus 1 minus theta times max of to show y1, y2, yn. How will I show this? How will I show this? Any idea? Any idea? So do you agree? x1 comma x2 dot xn. We did this last day, right? We can use a similar procedure. Is less than max of. So since we have learned what is infinity norm, I'm writing. Okay, no, because this is okay. x2 dot xn. Correct or wrong?
Yes, correct.
So do you also agree if you multiply theta throughout, that is also going to be true because it's a positive number? Similarly, your 1 minus theta times y1, y2 dot yn will be less than 1 minus theta times max of y1, yn. Yes or no?
Yes.
Now if I can simply add them element wise, what will happen? Theta times x1 plus theta 1 minus theta times, let's write it like this, 1 minus theta I don't like writing too much, right? I equal to 1 to n is less than theta times fx plus 1 minus theta times fy, correct? Yes or no?
Yes.
And now I can, since left hand side, right hand side is a constant, we can put a max on the left side. So you get f of theta x plus theta 1 minus theta y is less than equal to theta times f of x plus 1 minus theta y. Does this give you the complete understanding of functions themselves?
Sir,
Yeah.
sir, sorry,
Tell
sir. I'm very late to join the class actually.
Okay, no problem. We'll revise what we have done, but
Thank you, sir.
we'll do just, I'll tell you what we have done. We can see that you can see the last 30 minutes later because this is not going to be so much related to what we do next. We have learned
Okay,
that
sir.
a convex function has points, all the points above the curve, right? And we have shown that using convex sets. Okay. And then what we have done, we have shown that it is necessary for a convex function to have this, the linear combination of 2 points. The function of linear combination of 2 points must be, or convex combination is a special case of linear combination. So where the sum of the weights are equal to 1 is less than equal to the scaled value of the y's. Do you understand? So what we have done is, if you have a function like this, you have 2 points on the curve. The line joining them will always be above the curve. This is called a convex function. Do you understand?
Yes, sir.
Okay. And we have also seen that f of theta x plus 1 minus theta y, then what will it be? It will be less than f theta x plus 1 minus f theta y, right? Correct?
Okay.
Yes or no?
Yes.
Good. So that's what I have meant. So this is what we have done. We have shown using graphs as well. We have defined sets. You can see that convex sets, which is not very relevant for the next of the day, but I introduced it to explain convex functions. But you have understood what convex function is. Remember this graph for the time being. It will be enough for you to understand the rest of the session. Okay. Right?
Yes, sir.
Sure. Yeah. So let's do something. I'll just take a moment. Okay. Right? Let's see. So we will be doing what is called a gradient. Okay, a gradient of a function. So let's do it. So it's called a understanding gradients or derivatives in higher dimension. So we'll do this. So how do you do this? This is called x and y. So we'll have, say your function is multi-dimensional function. You may have done this already, but we'll be doing it again. So for a single variable function, do you agree that this is the derivative? Yes or no? At a point, dy dx, it tells you in which side the function is increasing, right? Is it increasing,
Yes.
decreasing? All those things tells you. But if you have a curved surface or a volume or a shape in 3D or higher dimension, what will happen? Can you define the derivative just like that? So I am not going to do directional derivatives, but I'll give you a specific directional derivative. So at the surface, you can have derivatives along this direction, along this direction, along this direction, any direction you can have or not, right? Because on any surface, you will have planes, right, that will cut through it. And every line on the plane will be, do you see, for in 3D, if you recall your 3D geometry, I don't know if you have done it properly in your college. A plane will be tangent to the curve, right, in 3D. And all the points on the plane will be a derivative, yes or no? Do you agree?
Yes. Yes.
Because your plane is touching the curve. So your every plane contains many lines we have seen in linear algebra. So every line will be in the tangent space. You can think of, and linear combination of all those lines will also be a tangent. Well done. So, but we'll do one thing. We will see in which direction is it increasing the maximum. That is, it increases in all the directions, right? That is given by the gradient. The gradient of function is given by d dx f I roof plus d dy. If you are doing physics, this is how you write, and so on, right? In maths, what do you write? You write this way. You take the function, take the derivative in all the partial derivatives in all the sides, and that gives you the side of maximum increase, right? That gives you the
Sir, can you
side
repeat
when
this
we.
once again, sir?
So in
Reading
physics,
equation.
yeah. So I'm telling, if you have a plane, right? So if you have a plane, you have many directions of gradient. But today we'll be only showing you the direction of gradient, which are where the function increases in all the directions. Or we'll be taking the gradient with respect to x in one direction, y in another direction, and z in another direction, and not in arbitrary vector with respect to any arbitrary vector, right? We'll get the gradient in the direction of x, y, z, the Cartesian coordinate, and that's called the gradient of a function. Do you agree? No? So
I
gradient
didn't
gives.
get it.
So you have if you have a multivariate function, do you agree if this is a multivariate function, z is equal to x1 square plus x2 square, right? And
Yes, yes.
x and y are two variables. So you will have a bowl like this,
Hmm.
and at a point you can pass a plane through it,
Yes.
and so you will have infinite tangents at that point. Yes or no? You will not have a single tangent, because every line on the plane which passes through that point will be a tangent. Yes or no?
Yes, 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 yes.
So we will be seeing only that tangent or that direction of the plane. We will be just seeing the direction the perpendicular to the plane, right? So we'll be seeing the equation of the plane only and not all the directional derivative, right? We'll be seeing
Okay.
the direction of maximum increase. We'll show you how. That's what I'm going to show you. The direction in which the function increases maximum. So you see now, I am taking derivative with respect to every Cartesian coordinate. Yes or no? So it will give me
Yes.
the derivative along each x, y, z, right? And finally, I'll get a vector which will be defining the plane of the maximum increase, plane of tangent or the direction of maximum increase. That's it. You don't need to think anything about this, but just look at this. Much more about this. I'll just show you. It will be easier to understand. See, do you see that these lines are called contour plots? What are contour plots? You cannot plot 3D or higher dimensions on 2D space, right? So what you do, you fix some points. So this is, say, z is equal to 2, right? So what will be this equation? This will be x square plus x1 square plus x2 square equal to 2 square, right? This will be the circle. Yes or no?
Yes, sir.
So if you fix this z at different points, so you fix z equal to 2, z equal to 5, z equal to 10, and so on, what will happen? So you will get larger and larger curves, right? Larger and larger circles. Yes or no?
Yes.
You will go upwards and you'll get larger and larger circles. So what you will be eventually getting is, if you take the gradient, what will be the gradient? Gradient of z? Tell me. 2x1 and 2x2, right? Or it will be equal to x1 comma x2. Yes or no? Right? Equivalent. A vector x1.
Derivative of
Yeah.
x1 square plus x2 square, na?
Yeah. It's a partial derivative, right? Along each
Yes.
So first, if you take a partial derivative of x1, what will you get?
2x1.
Correct. Partial derivative with x2, you will get 2x2. That's what I've written.
Yes.
This is the vector. You will get a vector or not? You will get a vector. Along
Yes.
how many coordinate components you have, you will get that many components in your vector. Good. So this is this line, right? Do you see this is the radius of these contours? So this gives you the grade this gradient gives you the direction of maximum increase. Is this clear? The radius along this direction gradient will increase. So along just in case of a 1D curve, it gives you the direction in which the Newton-Raphson method you can go up, go down along the gradient. Here also it gives you the direction in which the multivariate function is increasing rapidly, most rapidly, right?
Sir, how can you say that this is the maximum increase?
Correct. Good question. So for this example, do you agree this is the maximum increase?
For this example, it is every point will be maximum increase, na?
So it will be perpendicular to the contour. It has to be perpendicular to the contour to be maximum increase. Yes or no?
How can you say that? I mean,
I
in
can
this
say
example,
that. Go ahead. Yeah.
in this example, we can find out that yeah, it is the maximum increase. But for any
Yeah, I'm telling you
case-
why. I'm telling you. So why will it be the maximum increase? Do you agree in a contour, right?
Mhm.
The gradient is 0. Yes or no?
Acha.
Yes or no? Because it's constant. The function
Yes.
value is constant.
Yes.
So if you
Yes.
if
Yes.
you
Yes.
take the gradient, this is equal to c. So if you take gradient of f, this is equal to 0, right? So
Yes.
this tangent of this contours is no increase. So in which direction will you have maximum increase?
Perpendicular to it.
Very good. Maximum increase or decrease would be perpendicular to it, depending on the function. Is it clear now?
Mm.
Very good. Because you would any other component, you would have a component with respect to the no increment. There is no question of having any other direction, right?
Yes.
Your derivative should always be perpendicular to the curve or the contour lines. This is very simple things. Let's. I think you must have done it already, but I'm helping you to revise. Very good. But let's do it for a what. There is a very important property of a convex function. Let's see. This is also called the first derivative property, right? So first derivative property. Let's do it for this 1D case. You recall, have you all done Newton-Raphson method and so on? I think you should have done, right? So if you have not done, so you have x and y. Yes or no? You have 2 points. What is the value of delta? What is the value of delta? Can you tell me?
Y by x. Dy dx.
Dy dx, that is delta is dy dx. What are you saying? Delta is the distance, this height.
Oh. Oh. Acha.
Yeah. What will it be? It will be dy dx, or let's write y minus x tan theta or not.
Yes. 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 Yes.
Y minus x tan theta. What is tan theta? Dy dx. Please try to understand optimization very well. Otherwise, you'll not understand machine learning anything. So this is one thing. So do you see that f of y, right? Isn't it? So if you have this point, right? This is your f of y, correct? Yes or no?
Yes.
So your f of y plus y minus x dy dx,
Equals 0.
or no, sorry. So this is f of x, or f of y is this one, right? So f of y is this one. Sorry, you're saying yes. What are you saying?
No, I
Right? This
was
is
confused.
I have yeah. So this is your f of x. Yes or no?
Yes.
So your f of x plus y minus x dy dx, do you see, will always be less than f of y. This is your f of y, right? Yes or no? This tangent would never cut the curve, and the curve will be above it for a convex function, as we have all seen, like y equal to x square and so on. Is it okay? Do you see from geometrically why is it true? And I will show you algebraically also. This point, what is this point? This point is f of x plus delta, right?
F of x plus delta. Yes. Yes. Yes, sir.
Good. So f of x plus delta will be less than f of y. Do you agree or not?
Yes, sir.
This is what is Newton-Raphson method. So if you make delta very small, you can use it to plot a differential equation. So if you're given f of x comma y, if you are given the derivative dy dx, you can use it to plot. So you can get xt plus 1 as xt plus some h, and yt plus 1 as yt plus h into dy dx, right? Yes or no? So if this is very small, you can trace the curve like this, right? Let me draw it in some other color. If your h is small, right? I'm taking this as the proxy of fy. Do you understand, everyone? If it is very large, your x and y, that gap between x and y is very large, you will have a big error. But if it is very small, no error, yes or no?
Yes.
That's how you define gradients or tangents and derivatives. So this is known as the Newton-Raphson method of plotting curves. This is what your softwares do. So let's do it geometrically, algebraically also. What will be algebraically? How will I do it? Very simple. So what is the property of convex function? F of x plus 1 minus y. Y is less than equal to theta times f of x plus 1 minus y f of y, right? Yes or no? This is what we have defined. What happened? Everybody else fell quiet. So f of x. So you will have f of y plus 1 minus theta times x minus y. Yes or no? Are you following? Just remember, the convex combination of 2 points will be less than the function value at a convex combination of 2 points will be less than the convex function of the convex combination of the function value at those points. Or you can just remember a curve of facing downwards and 2 points on the curve, and every point on the line will be above the curve. Right? We have already seen this 10 times. So theta into f of x minus f of y plus f of y. Is it okay? Can I write this?
Yes.
Now what can I do? If you have understood what we have done all this while and use your class 11 calculus concepts, you can easily find out this thing. What will I do? F of y plus, little bit you use your common sense, you'll be able to do it. Minus f of y, right? Correct? Yes or no?
Yes.
Very good. So had it been a 1D case, right? So we'll be putting limit x tends to y, right? X tends to y plus, to be exact. Had it been a 1D case, I could have subtracted x minus y and multiplied by x minus 1 and got a derivative at y. Yes or no? I would have got that. Because this would become your h and this would have been your h. Yes or no? Which would have
Yes.
become f of y plus h minus f of y by h. Limit h tends to 0. This is equal to dy dx. Dy dx. Yes or no? At
Yes.
yes, or you can write it as f prime of y. We could have written. Very good. But since it is not a 2D case, but in 1D it is straightforward. We can just multiply like this in 1D. In 1D we can just expand this and you will get f of x less than equal to f of y plus f dash of y x minus y. Right? We have proved this. See here, if you interchange the x and y, you will get this equation, right? There's no problem interchanging x and y. They're just dummies, right? No doubt.
Yes, sir.
Have I got x is here, y is here, x is here, y is here, x is here, y is here. So I've just interchanged x and y, so you'll get the desired, or I have written something wrong over here, so it should be this, right? This, you're saying yes, right? Yes or no? Correct? Let's see. If you have not understood, let's expand this now. But for multivariate case, there is no question of division, right? I can't divide. So what will I have to do? Multivariate is this is your x minus y is a vector. Do you agree? Which will be in your machine learning, it will be a vector. Yes or no?
Mhm.
You'll have a pixel image, and from the image you'll have to predict, or the image you'll have to generate. So there's no question of having one dimensional. So what will I do if it is not one dimensional?
We'll make contours.
Now, what happens? Can't you do a Taylor series expansion of this? That's what you can do always. If you do a Taylor series expansion, what can you write? So this is, you please look up multivariate. See, first variable, whatever you will have, multivariate, you will have gradients. That's how you replace it. I could have just written f of y here, but I'm just showing you why it is, why you have, what you have to actually do in practice, right? And plus other ordered terms, right? N squared terms, which are small. Yes or no?
Yes.
Divided by theta.
Theta.
Good, is less than f of x minus f of y, right? So what will I
Yes.
have? So your f of minus f of y is already there. So this and this will cancel, and you will be left with only this term. So this will become f gradient transpose of y. So everything is falling into the groove. See, you're using your matrix theory to take inner products here. This is actually inner product. Do you agree? Inner product of x minus y and the gradient, right? Which is equal to f of x is greater than f of y plus gradient of x minus y. Which, what does it mean? It means, or I can interchange x and y. Hence proved, yes or no? Everybody understood? Or if you have a doubt, you ask me, we'll go to the next question otherwise. Have you understood how I have converted this figure to a, and I've proved this equation? Everyone? Yes or no?
Yes.
I hope it is clear. Now, if you have understood, show that why are convex functions important? Saptoshi was pointing it, maybe he was telling why is convex function or something. So he was asking why is convex function so important, or I don't know, I was only asking. So I said it is important. Now I will tell you, because it has a single local minimum and unique minimum. So it has a local minimum is equal to global minimum. This is why convex function forms the heart of optimization. So you'll have courses, semester-long courses just dealing with convex functions, convex optimizations, right? So tell me, local min, how will I prove that local minimum is equal to the global minimum? I'm giving you a hint. Your function is differentiable everywhere. Assume. Yeah. Can you tell me? So what will I use? If you have understood. So f of y we said was, yeah, go ahead.
Greater than equal to.
Yeah, greater than equal to f of x.
If transpose y minus x. X minus y.
No, y minus x only, because, or x minus y. Y is
Y,
greater,
y
no?
minus x.
Because we have seen in the figure. Whenever you are confused, draw this figure and see. Every time you don't need to derive, right? You can just draw this figure. Your f of y is here, and this is f of x plus h into dy dx. Just draw like this and see, right? This is x, this is y. So now, if you have understood, like I want someone else, like Hussein has understood. Others, can you tell me how will I prove it? That your local minimum is a global minimum. What does it mean? There is only one minimum like this.
We will differentiate with respect to x.
So
on both
differentiation is already there now. That's why I am telling. Differentiation is already there. This is a derivative. Yes or no?
sides. Yeah.
So if x star is an optimal point, right? So do you agree f star y is greater than if x star, I'm putting x is equal to x star plus. Now everybody, who if you have understood what is the value of gradient of x star? Not a difficult thing to say. What is the value of a derivative at minima or maxima?
0.
Others, what happened? Why did you fall quiet? Yes or no? So do you agree x star is less than all points? Because y, you can choose any y now.
Yes.
Very good. So, but you can also have functions like this, right? Mod x. That is also a convex function. Do you agree? And it is not differentiable at the minima. Then how will you prove? For functions that are not differentiable, how will you prove? How will you prove? So we have to prove. How will you prove basic proof? How will you do a basic proof? What will you use? We'll be using the definition. Always use the definition when you have a new question or something like that. So what is the definition of a convex function? Yes or no? Correct? Now what will I do? What will I do next? Let's say, what will I say? Let's say give me an example. Let's say your x star is a local minima. Do you agree? If I say that x star is a local minima, what can I do? Tell me. Let's denote this point as some y tilde. And let's say x is equal to x star, right? So, correct? Yes or no? I can write this plus 1 minus theta into f of y. Yes or no?
Yes.
Now let's say, what did I say? Local minima is a global minima. What did I prove you or show you all this while? To prove by contradiction. Let's say x is not a global minima. Right? That is
Right.
f of y is less than f of x. Let us say. Okay. Are you happy with it? Yes or no? So I will be putting, can I upper bound this by f of x 1 minus theta f of x star? Yes or no? This is greater than. Yes or no, others?
Oh yes, we can do that.
Yes.
So do you see that is, this is what? This is nothing but f of x star.
Theta
Correct?
plus 1 minus theta.
Correct. And we had shown that y tilde was not a global maxima. So y tilde turned out to be a minima. This is contradiction. So x star is not a minima. Then this is not possible. This thing is not possible from the very definition of a convex function. Clear? So this has to be very important. I'll write in block letters. This is why it is very nice. So if you have a linear regression, it's a complex, it's a convex optimization problem. If you have a logistic regression, it's a convex optimization problem. At the end of the day, you will have a unique solution to that problem. There is no two solutions. But in your neural networks, which is not a convex optimization problem, you can have infinite solutions, right? convex optimization problem has a unique global minima. Happy? Everybody is okay with it? Okay. So I'll give you a second, will not do anything related to the second derivative, but people may ask you, do you agree that dy dx, d2y dx2 has to be greater than 0 for a minima? Yes or no? Good. So in a 2D or more higher dimensional case, you call this a Hessian. And this is called a positive semi-definite. We have seen matrices, yes or no? We have seen matrices. What does positive semi-definite mean? I will just give you one more definition on matrices. It means all eigenvalues of F are positive. So if you see some book where they talk about why these eigenvalues have to be positive, I can give you the intuition using this. So this also means X Hermitian, say H is the Hessian matrix. So this is called a Hessian matrix. And X. Do you agree this is a quadratic? Yes or no?
Why?
How can you? Okay, very good question. Why? So I have A1, A2. Let's say A11, A12, A21, A22, right? And I have X1, X2, right? This is your X and X1, X2. Let's consider real numbers only. Hermitian ka jhamela will not take. So what will you have? Will you have A11 X1 plus A12 X2, A21 X1 plus A22 X2, right? Yes or no? Correct? Next, what will you have? A11 X1 square plus A12 X1 X2 X2 X1 X1 X2 plus A21. So I can put A21 over here. X1
Yes, it
X2
will come quadratic.
and you will have A22 X2 square. So now, if this has to be greater than 0, right? What has to be happening? Your b square minus 4ac must be less than 0.
Yes.
Right? You should have it above the curve since and a11 has to be greater than 0, right? Then you will have a quadratic like this. So that's what will give you a12 plus a21 squared minus a4a11 into a22. From this condition, you will get all the eigenvalues have to be positive for a positive semi-definite matrix or 0. Right. So you can see the sessions related to this. There are a lot of Gilbert Strang has a later video which does this on it. It is in his book. I have given it. There is also that. But since we do not have so much of time, this is more on linear algebra and machine learning. So we'll be seeing this when we are doing machine learning or something like that. But is the intuition clear that for the second derivative must be greater than 0? So this has to be greater than 0. Do you agree? If this is greater than 0, I can give you more intuition if X is an eigenvector. Do you agree? Lambda X square is greater than 0 if and only if lambda is greater than 0. Yes or no? What do I mean?
Yes.
Hx is equal to lambda x. If it is true, I am going to multiply these two and convert it into lambda x from the eigenvector. And what will I have? This is already positive. To keep it positive, your lambda has to be greater than 0, right? Okay. Are you okay with it? So you can write any x as linear combinations of all all eigenvectors, and then you can take the right. Any x can be written as alpha I xi's, where xi's are the eigenvectors, right? Similarly, if you do that, because it will give you a basis, right? In the eigenvectors will give you a basis, as you have seen before. Leaving this long story short, your eigenvalues must be positive and your Hessian must be greater than 0, or for single variate case, your second derivative must be greater than 0. So do you agree log x is a convex function? How will you prove it? If you have understood, how do you prove log x is a convex function? Yeah.
Showing that it falls into the definition of.
So
Can we do that?
right? Yes or no?
Yes.
Correct? Which means it's a convex function. Correct? Everyone?
Ah, okay.
Good. So now I'll wait for 2 seconds. If you people do not have any doubt, I'll be good.
Could we not do it by showing that it?
You can do it, but it will be lengthy. Yeah.
Yes.
The log of theta x plus 1 minus theta y, you have to expand it using Taylor series or something, but it will not be very simple thing to do. Well, that's why you need other, you will have to do a lot of analysis to get that. Compared to this, it is just one liner. So let's start with what is called a Jensen's inequality. I have used Jensen's inequality last day in your Holder's inequality, right? You have used Holder's inequality extensively last day. So, but today, let us prove what is the Jensen's inequality. So, this will integrate your linear algebra and probability together. So, others, Saptoshi, is it okay if I move on? If
Yes.
you are okay. So, again, I will give you a trick to remember the Jensen's inequality, because the proof is not very easy. Even I have to look up the proof multiple times when I have to explain to you. So the proof is not trivial. Every professor looks it up every time because there is some technicality, but you can remember it very easily. How do you remember it? This way. So there is a this is your x, this is your y, right? If you have a convex function, this will be the picture. Yes or no? Correct?
Sorry, sir. কেটে গেল. The
Yeah,
voice
yeah.
just broke up.
আমি বলছি যে if it is a convex function, তাহলে কি হবে? What will happen? If it is a convex function,
then-
what will you will this line will be above the curve, yes or no?
Yes, it will.
It will be above the curve, as we have seen. So do you agree that if I take the linear combination of these two, you will be somewhere here? If you take the convex combination, some p and
Yes.
minus p, right? This is your f of x, this is f of y, yes or no?
Yes.
But do you also agree, if I take the linear combination of x and y, I will also have my f of px plus 1 minus py will be somewhere here, yes or no?
Yes, sir.
So px into, we have seen this, px into 1 minus py, what can it be written as? If summation of pi is equal to 1, is it a PMF?
Yes.
It's a probability mass function. So by
Yes.
so this is expected if x and y belong to the range of a random variable. Can we write this as expected value of x is less than
It's greater.
expected value of f of x, right? Because these are f of x and you're taking the expected value which is above, yes or no? So in some way, as Saptoshi, I was telling you, linear convex combination is a restricted linear combination where the summation of each component is equal to 1, right? each component is equal to 1, and what happens if the summation of each component is equal to 1? What will happen? It will be a PMF or not? It will be a probability mass function.
Yes. Summation
Correct.
of all the components become 1.
Yes, so the probability of each component is 1, then it's a probability mass function. So if you have the expectation inside the function, so if you're taking the function value of the expected value, right? The expected value of an x and y is this point, and the function value is here, yes or no? Which will be less than the expected value of the functions, right or wrong?
Yes.
So this is very much used in your elbow and other related to machine. Everywhere it is used, information theory everywhere, but related to your machine learning, it's used in VAEs, variation autoencoders, and all variation learning questions. Okay. So let's prove it. How do I prove it? It's a technical proof, as I told you. So if I have to look up to my notes, please forgive me. I'll try not to, but let's see. So let's say your x is equal to c, right? If you have a random variable, x is equal to c, is it a constant random variable, right? Base case.
Yes, sir.
Everyone, is it okay? What is the probability of x equal to c then?
Yes.
Probability of x equal to c? If you have understood. What is the probability? If it is a constant random variable, x can take what value? Whatever event occurs, the random variable will return only c or not?
Yes. And 1.
Yes. Probability is 1. So what is the expected value of x then? The
C.
constant is c. So f of expected value of c is f of c. Yes or no? Right?
Yes.
So similarly, expected value of f of c will be, or f of x will be 1 into f of c.
Yes.
This is probability of x equal to c. Good. So they are both equal here, right? So equality condition holds for a constant random variable. Okay. Now let us do something. Let us consider a simple random variable or a discrete random variable such that x maps from the sample space to x1, x2, dot, xn plus 1. Okay. Very simple. Like the proof formulation is very simple. There are few technicalities, but it is very simple. X is equal to xi is equal to pi. Is it okay? Like head probability is 0.5, tail probability is 0.5. Here there is, say, 6 outcomes, 10 n outcomes. Is it okay?
Sir?
Yeah. Yeah. It's, you are saying yes or no. You said yes, or you want to you have some clarifications or questions? Any question? Hello.
No.
What is not clear? So you have n outcomes, right? So it's like 1, 2, 3, 4, 5, 6 of a die roll. So the each has a probability p1 and summation of this is equal to 1.
1.
Good. So now from this I will be making another random variable. Make y mapping from x to, so here is what I'll be doing called, will be an induction, right? So please, if you're not understanding, tell me. I don't want you to fall quite. There's nothing difficult that I've done yet. I'll be doing it now. So this is the new random variable, right? And then I am going to write the PMF of y equal to x1, xi equal to pi by 1 minus p1. Is it okay? Is this okay? Or now there is a confusion. If you have a confusion, ask me. Now it has n outcomes, yes or no?
Yes, sir.
So how can you say this is a valid PMF? How can you say it's a valid PMF? For being a valid PMF, what has to happen? Right, sum of
Summation of all
yeah.
the probabilities should be 1.
So summation of all probabilities from 2 equal to n plus 1 by 1 minus
1.
p1. This is equal to what? So what can you write this as? Do you recall that summation of all pi's from 1 to n plus 1 was 1?
1. So 1 minus p1.
Yes. So it will be 1 minus p1 by 1 minus p1. This is 1. Correct? Valid PMF, everyone?
Yes.
So let us assume that the Jensen's inequality holds for it. Holds. That is how you do for n length. So and then we'll show for n plus 1. Correct? This is an n length n outcome space, right or wrong? Yes or no? If you can there are n outcomes here. Now if you can show it is true for n plus 1 also, we are done. That is how you used to do in school. If it is true for n and true for n plus 1, it is true for all n, right?
Yes, by induction.
Yeah. So now, what did we say? F of expected value of, what can we write? F of expected value of y. What can I write it as? Less than equal to expected value of f of y.
F of y.
Yes. So what will be the left hand side? Please somebody tell me. I want, if I keep on writing, you will not follow and you will fall asleep. What is the left hand side? What is the expected value of y?
That
Tell me. What is the expected value of y? We have done, na? Y into p equal to y. Probability y. This is the weighted average of this weights. What is the expected value of y? Average of y, what will it be? Summation of I equal to 1 to or 2 to n plus 1 here. These are the outcomes. Pi by 1 minus p1 xi, yes or no? Sorry. So expected value of x is what? Summation of x is equal to k into k, yes or no? Over all k.
yes.
That's what I've written. This is the case, and this is 1 minus p1. So this will be equal less than.
Yes.
And now the right hand side, if you have understood, tell me.
Expected value of f of y.
F of y, yes. What are the outcomes possible for y? By lotus, f of xi, yes or no? Your lotus, what did lotus say? F of expected value of x is, yes or no?
Yes.
Same thing, na? What is the problem you do? I don't know.
Sigma equal to 2 to n plus 1 pi, right?
Correct? Now what will I
Yes,
do? Good. So now what will I do? I will be making, now what is my objective? I have to show that I have to convert this summation to I equal to 1 to n plus 1, right? This is the objective. This is how you should think about maths. If I can convert it to from 1 to n plus 1, I'll be done. Because true for n plus 1 outcomes also. So it is true for all discrete outcomes. You can make it continuous by considering all countable sets, right? All countable real rational numbers, yes, which is P by Q forms are countable sets. And there is real analysis which you'll be doing in higher studies, and you can convert any real rational numbers to real numbers. So if you show it for any discrete random variable, you will be able to show it for continuous random variable. This is the idea.
But you said
Right?
rational numbers are countable.
Yes, rational numbers are countable. P by Q, right? Where P and Q both are countable, right?
By the rainbow method, we can prove it, right?
Yes, you can also prove by a like this method, 1 by 1, 1 by 2, 1 by 2, and so on. That's a, this is what you're telling rainbow method, no?
Yes.
Yeah. So rational numbers are countable. So but there are infinitely many rational numbers. They are also packed. They can be used to approximate real numbers. So there can be a bound on rational numbers between two real numbers, but will not don't people will fall out if I go into that. Leave it. Okay. So from 1 to n plus 1, right? How will I do it? Now you can tell me. I did not require to look at my notes for the proof. Good. What will I do?
Add by P of 1 and then subtract.
Exactly. That's similar to that. So I'll be doing something like this. I will be making a third random variable, z, which will be x1, comma, all these points.
2xn plus 1.
2 to n plus 1 py plus 1 minus py xi, right? If I can write this, now you tell me what is the expected value of z, or let me write the probability. Let me write of z equal to x1. What is the probability z equal to x1? P1, right?
Yes.
What is the probability? I'll be writing z equal to this term. I will tell as rest.
1 minus P1.
1 minus P1. So what is the expected value of z? Tell me.
P1 by 1 minus P1 x1.
Yes, so it will be P1 x1 plus summation of 1 minus P1 into Pi by 1 minus P1 xi, right? Yes or no?
Oh, yes.
So this is nothing but what? I equal to 1 to
1
n
to
plus
n.
1
Say 1 to n
1
plus 1.
Pi xi. Yes or no? Now from definition of convex functions, right? If I put a f outside here and f is convex, what can I do?
Then it will be less than equal to expected.
Yes, it will become P1 f of x1 plus 1 minus P1.
Sigma of I equal to 2 to n plus 1.
Very good. Very good. Now everybody is understanding. P1 Pi by 1 minus
1
Pi
minus
x.
P1 xi.
Very good. So this is what? This on the right hand side. What can you do this for this? You can see I have mentioned this here. So from inequality 1, I can upper bound this by this one or not? This term. I have already have an upper bound for this.
Yes.
This is 1. So P1 f of x1 plus 1 minus P1. What is the upper bound? Pi by 1 minus Pi, right? F of xi. Yes or no? Correct? Is it okay? I have just put this upper bound. It is greater than the left hand side. So what did I get? So this is you will accept this is your expected value of z. Yes or no?
Yes.
And the right hand side is your expected value of
P1 and
yes. So this is equal to what? Pi summation of Pi f of xi I equal to 1 to n plus is equal to expected value of f of z. Correct? Have I proved it? So z, this is for
for 1 to n plus 1.
This is actually if expected value of not z. This is expected value of what? Initial random variable x, right? 1 to x plus 1 is here, right? Z is two binary random variable, yes or no? Not understood? X is between 1 and n, right? 1 and n plus 1. Z is just two numbers, a and b, if you think. So x is, it is true for n plus 1 outcome space also. So true for all. Is it okay with everybody? Is it okay? Okay. So for vectors, what will it be? Can you tell me? So special case would be for vectors also there is a Jensen's inequality. For Jensen's inequality for vectors, what can you do? Any idea? I've proved the Jensen's inequality. For vectors, if I say x is equal to x1, x2, dot 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 xn, right? Okay.
Yes.
I can say summation of I equal to 1 to n 1 by n xi is less than equal to f of xi 1 by n. Yes or no? If, how can I do that? I will say these are equiprobable. Correct? If I say x1 to xn are equiprobable, this is true or not? If they are equiprobable, the probability of x equal to xi is 1 by n or not? There are n outcomes.
Yes.
So what is
yes,
the
yes. So equiprobable then 1 by n.
yes, so 1 by n f of, so this is in case of vectors. This is also correct. So if you have a vector, you can write f of 1 by n summation of the vectors is less than this. Okay. Good. So let us prove. So last day, do you recall that we have proved the Holder's inequality, use the Holder's inequality throughout? Yes or no? We have proved the Holder's, we have used the Holder's inequality. This one I gave you a homework also. Anyways, and we said 1 by p plus 1 by q equal to 1. Yes or no? So I want you to use the Jensen's inequality to prove the Holder's inequality. How will we do it? Not a difficult task. We will do it something like this. So expected value of f of x, right, is less than yes or no? Do you agree? This one we know for a fact. Is it okay? Okay. Yeah, we know. I'm using this is the Jensen's inequality we have proved just now. Please bear with me. If you are please try to follow. Now forget about the Jensen's inequality proof and concentrate on this proof. Because we'll be showing eventually that P and Q will form a vector norm where triangle inequality will hold. We have not shown it last day. Finally, we'll show it. Good. So x summation x equal to, and we'll prove a general case of this first. We will not prove this case, but we'll be proving it for random variables. If we can prove it for random variables, 1 by n equal probable thing we will prove for vectors or not. You can prove it for vectors from random variables. This is why I said today we will be linking linear algebra and probability. Okay. So,
Yes.
so what can I take? So x, let us say, is a random variable that maps from x to p log v and q log w. Is this okay? There's no problem. Two outcomes. Right? Just think these are 0 and 1, some label, right? Therefore a reason I'm taking this, right? And just, so I'll be copying this part and doing it at the end. Copy. Oh, we are almost done also. Very good. So these two proofs we will do, and then it will be simple, like 1-2 lines of calculus, which is a cakewalk for you. Again, I'm doing this. Sorry. Okay. How will I prove it? So, do you agree if I say probability of the PMF equal to 1 by P and 1 by Q? I can define PMFs like this. Why can I do that? If you have understood, that is the probability of.
Because 1 by P plus 1 by Q equal to 1.
Very good. Pay attention, everyone. Finally, he is paying attention. So X is equal to P log V is equal to 1 by P. So you have understood what I'm meaning, right? So what will be your expected value of X then, if you have understood? Tell me. Expected value of X will be 1 by P into
P into
yeah,
R
log
log
B. Yes. And Q into 1 by Q into. Tell me, Saptarshi.
Q ln
W. This one you are telling this one, Saptarshi, right?
Yes.
So this is your log V and VW, right? Correct. Now let us define a function f as e to the power x. Right? Do you agree e to the power x is a convex function?
yes.
d2y yes is equal to e to the power x, which is greater than 0. Also from the graph you can look, right? Any 2 points, right?
Yes, sir.
So why am I taking e to the power x? You will see now. It's become so simple now. So f of expected value of x, right, will be less than equal to expected value of f of x, right? So what is f of expected value of x? E to the power log of VW. Do you agree? Yes or no? This is what we found, expected value of x to be. And then less than equal to, what will it be? P into, let me write, f of expected value of f of x. F of expected value of f of x কি হবে? কি হবে? Expected value of f of x?
So shouldn't it be e to the power x expected value of x?
This one? Yeah, this should be e to the power. This
Above.
one, left hand side.
No, above.
Yeah, which one?
That f equal to e to the power x.
I'm just defining f of x is equal to e to the power x.
Okay.
You are right. So that's why I'm telling f of expected value of x is a composite function, right? That's what I've written. So what will be effective value, expected value of f of x? Can you tell me? Do you agree this will be p into what? What is f of x? First tell me. This is not good. You're not responding.
Correct.
E to the power x.
E to the power p log v. Yes or no? Comma. E to the power q log v, log w. Yes or no? This would be your p. This will be the outcome space of f of x. Yes or no?
Yes, sir.
Good. So what will you have? the expected value as p into e to the power of log v to the power p plus q into
e to the power log 1 to okay.
very good e to the power of log of w to the power q. Yes or no?
Yes.
So this is nothing but v to the power p by p plus w to the power q by q. Do you agree? So we have got an equation vw less than equal to v to the power p by p plus w to the power q by q. You have got this equation?
Yes.
Now comes the trick. What trick will I use? I will use this trick where I will be saying I will be now I'll for the first time I will be defining what is called a norm of a random variable. Norm of a random variable. What is the norm of a random variable? Can you tell me? We have defined norms last day. So what should be the p norm of a random variable? Very simple. It should be from the from a vector you have this. Do you agree? This is what you have for a vector? Yes or no? This is how you define the p norm. So if I divide by 1 by n, the properties won't change, but will it become a I'm just trying to give an analog to a random variable. Will it become a probability distribution? If all the xi's are IIDs from the distribution? Yes or no? So what I try to come at is I want to say this is expected value of p to the power x to the power p by 1 by p. Aren't these two analogous? Do you see the connection between these two? So this is not there, not generally there in p norm. We do not need it, but we can write it, right? So there is no problem of writing this because 1 by n is just a constant. You can take it out, right? All the properties would still hold, isn't it? Let's put it this way. If I say x by n, is this allowed? Is this okay? Oh, you are thinking, why am I writing this? Right? This is what you are saying. So this is a analog
Yes.
in case of a random variable. Anyways, so if I take v to be a random variable x by its p norm and w to be a random variable y by its q norm, right? Do you agree? I can take any values for v and w and then take expectation on both sides. What will I end up getting? I will get expected value of xy by expected value of.
Can you repeat these lines?
Yeah, I'll repeat. Let me write it down, then I'll repeat. Okay, I took v as a random variable x by its norm. I can do that. It's just the
Yes.
and w another random variable y by its norm. I can do that, no problem. Then what I did, I just put the value over here. I can do that. I have put the value in this equation. This one.
Yes.
And
then
taken
got it.
expectation on both sides. So what is this? This thing? Do you agree this is yours? Yes or no? Do you agree the numerator is norm of pth norm of x to the power p?
Yes, it is.
And this numerator is qth norm of the power p from this definition. I hope both understand. Everyone understands this?
Yes.
So what will I have? This will become 1 and this will become 1, right? So
Yes.
I will be left with expected value of xy less than equal to 1 by p plus 1 by
1 by p
q.
plus, which is equal to 1.
Very good. So we had used this extensively last day, but since we did not know Jensen's inequality and optimization, we couldn't use it. But we have used it in terms of linear algebra. We have not used in terms of the random variable. So how do you convert it to a linear algebra case? Can take x to be x1, x2 dot 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 xn, right? And y to be y1, y2 dot 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 yn. Happy?
Yes.
Then expected of this value and equal probable, 1 by n each probability. 1 by n each probability. Is everyone following? This is okay for everybody?
Yes.
So now what will, if you're following, what will be the expected value of xy? Do you agree it will be xi yi summation of I equal to 1 to n 1 by n squared? Yes or no? The probability of getting
Yes.
a pair like this will be this, because they are IID. I'm taking them to be independent. Very good. Similarly, what would be the right hand side? Can anyone tell me? And then there will be a mod on individual components. What would be the right hand side then? Nothing but this, right? Xi to the power p 1 by n to the power p summation of I equal to 1 to n 1 over p. Yes or no? This is how I defined a norm. If they are equiprobable, what will happen? I will get xi to the power p into 1 by n to the power p, correct?
Yes.
Summation of I equal to 1 to n. This is the probability 1 by n. Why am I writing to the power p? 1 by n is the probability, right?
Yes, sir.
Good. Let me write it in a fresh manner, and then it will become much more clearer. So x comma y, xi comma yi, right? So what is the probability of expected value of xi yi? What does it mean? Can you write from the first definition? Summation of x is equal to xi comma y equal to yi, right? Yes or no? And they can be only one of them, not all of them, right? Into xi yi. This is how I am taking. For I equal to 1 to n. Say I am x is occurring, then yi is also occurring in some relation. So you will be having this as less than equal to what? You'll have this less than equal to expected value of mod of xy. Yes or no? The joint probability, is this the definition or not? Okay, let me see if you're understanding or not. So the p norm is again the expected value of x to the power p 1 over p, right? So what is the value? Xi to the power p? Yes or no? Xi to the power p?
Yes, sir.
1 by n, I equal to 1 to n, right?
Yes.
The probability into, so this is the probability of x is equal to xi into xi to the power p. This is the definition by Lotus. Similarly, I will have I equal to 1 to n, 1 by n, yi to the power q into 1 by q. Yes or no? Right? This is okay. I'm stopping.
Yes.
Now I will, what will I do? I will take 1 by n, p plus q outside. Happy? What am I again wrong? You're not happy. This outside, because 1 by n is common for all. I can take it outside or not? For both of them? Right? I think it is trivial for you. Good. So this is the your vector norm for vectors. This is how we define for vectors. Correct or wrong?
Yes, yes.
I have just taken this n out and this n out. Similarly, I define this joint probability as 1 over n. Right? So, and probability of x is equal to xi, comma y equal to yj is 0. This is how we can define a joint probability, yes or no? I can define any probability I want. Correct? No problem. This is a valid joint probability, right? And if you marginalize over all the y's, what will you get? You will get 1 by n. I'll show you anyways. So if this is 1 by n, you will get summation of xi yi I equal to 1 to n less than equal to, what is n to the power 1 by p plus 1 by q? Tell me.
1 by n.
Very good. 1 by n, vector norm, vector norm. Right? What does this mean? This is, do you agree? This is greater than summation of I equal to 1 to n mod of xi yi. Do you agree or not? Right? Because xi is greater less than a mod of xi. Same rule, right? Any term ti is less than mod of ti. So summation of ti would be less than summation of mods of ti, right? On the left hand side, it's not independent, so you can take the mod again. Is this clear? Or do you want me to tell again? Array.
No, sir, it's clear.
Yeah, because mod is always greater. If you sum them and take mod, you can have only smaller numbers, right? That's up. So this is what W transpose X less than. Is everyone happy with it? Is the Jensen's inequality, is the Holder's inequality proved? So for complex case, this is true. Is everyone okay? So there is one thing that is not okay. Can you point out to that? And I will show you that just now. If you have followed all my sessions till now, you should be able to tell me what is not okay yet. Tell me. That is the definition of the joint probability, right? Probability of x equal to xi, comma, y is equal to yi, I said equal to 1 by n. And I have also said probability of x is equal to xi is equal to 1 by n. And I have said probability of y equal to yi equal to 1 by n. Can you tell me how can I show that this is a right choice given these two are my choices? My choice. I have to show this is a right choice. How do I show that? Any idea? We have shown this many times. So if I have to get probability of x equal to xi, what will I have to do? If I have to get probability of x equal to xi, what will I have to do? If I have probability of x joint distribution of xy, and I want to get probability of x, I have shown this law of total probability 100 times to you. What will I have to do? I have to integrate y out or not? Or in case of a discrete random variable, I have to take the sum of all the random variables of all values of y by law of total probability. Please refer to the 1 to 4 sessions, which have been very long. So if I sum over y equal to y1 3yn, or 1 equal to 1 to n, 1 to n, probability of x is equal to xi, y is equal to yi. Right? What will I get? I have said probability of given probability of x is equal to xi and y equal to yj, I have said equal to 0. So I have said these two can never occur together. Only these corresponding things can occur together. Right? Is it okay? Then do you agree this is nothing but equal to? Are you okay with this? Tell me what is not clear. I'm not understanding because this is very trivial matter. Generally, if you tell me, I'll be able to explain. Anything you want to tell me? I am marginalizing y. I am so there. What are the outcomes y can take? y1, y2, dot dot dot, yn, right? So y1 to yn I have taken, and x is equal to xj I have told you. So for all y equal to yi such that I not equal to j, what will happen? I have said they are 0 probability. They'll become 0 only when y equal to yj, it will remain and it will become 1 by n. Is it okay? Hello, am I
Yes.
audible? Okay. So now we have proved it for a general case as well. So we had enough space here to show this. Good. Let's do the Minkowski equation. So do you see convex function, Jensen's inequality, bringing linear algebra and probability under the same hood using the Holder's inequality? Finally, I'll be proving the norms. P is a valid norm. Do you agree this has to hold for P to be a valid norm? Other things are holding, homogeneity and positivity. A triangle inequality must hold, as you were pointing out yesterday. So how do I prove triangle inequality for the P norm? Right? So P is greater than 1. I'll show you why P has to be greater than 1. Tell me what will I do? So left hand side, what can I write? Let's consider x plus y p to the power p. What will it be? The Pn norm. Consider matrix norms only, your linear algebra norms only. What can I write this as? Summation of I equal to 1 to n xi plus yi to the power p. Yes or no?
Yes.
Next, what will I do? Can you use the Holder's inequality to, I have given you the hint that you have to use the Holder's inequality. So what will I do? Let's write it this way. So the way I am writing, you will not forget. So xi plus yi to the power p minus 1 into, is this okay?
Yes.
So now can you use the Holder's inequality? So I will say your x vector is x plus yi to the power of p minus 1, x1, x2 plus y2 to the power p minus 1, and xn plus yn to the power p minus 1. I can tell this is my new x vector. And I can also say my new y vector is x1 plus y1, x2 plus y2, dot dot dot, xn plus yn. Isn't it? I can say this. Yes or no?
Yes.
Good. So can I do LHS less than equal to what will I write? Can you give me a Holder's inequality form for this? So first I'm using the triangle inequality. So I was a bit wrong. So let me write y, not that wrong as well. So y1 is equal to x1 dot 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 xn mod and y2 as y1 dot 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 yn mod. So LHS will be less than equal to, do you see by triangle inequality? This I can break as mod of xi plus mod of yi, yes or no? By triangle inequality of modulo operation. We have already shown this just now. Right? So what will I have? Summation of I equal to 1 to n xi plus yi to the power p minus 1 xi plus summation of I equal to 1 to n xi plus yi to the power p minus 1 yi. Yes or no? Right?
Yes.
So now, do you agree I can use the Holder's inequality that I have already shown you below? Right? So what will be my Holder's inequality? X plus y, right, to the power p. Okay. I'll be using, so p minus 1 I have for this vector. So this is my new vector, yes or no? Right? Correct or wrong? So can I write this way? Q? Right? Just tell me if it is okay. I want to bring p on the outside, right? Correct? This is the Holder's inequality, right? Xi, yi is less than equal to, we have shown. Correct? Yes or no?
Yes.
So now I can take this common. So what do you expect this to be? If you have like having the understanding of mathematics, what should be your expectation that this will turn out to be? What am I writing? So on the left hand side, what do you have? X plus y to the power pth to the power p. So what do you expect this will turn out to be for holding the Minkowski identity? Any idea? Let's see.
Can you just repeat this? What you're doing, because I was disconnected.
Yeah. So we started off with this. Is this step clear? So the pth norm of a vector is this, right? Please be unmuted. Yeah, and I broke it up into p minus 1 and
Yes, I
another.
can do it.
Yeah, since
minus
p is
1 into
greater.
p.
Yes, since p is greater than or equal to 1, I can always do that. And then what did I do? I use the triangle inequality to expand x and y separately,
Yes.
because here this is greater than or equal to, separately taking the mod of each of them. And then I use the Holder's inequality. Correct?
Yes.
Holder's inequality that I have used over here. So Holder's inequality, I have taken p on this vector, p on this vector, q on this vector. Okay. So now I want to show it for this vector is equal to. So if you are having a little bit of, if you're following my sessions, it will be this, right? Because I want to take this p out with this. Correct or not?
Yes.
So let me show that it is indeed equal to that. So what is this? Summation of. So there is a misconception about my writing. So please bear with me. So let me write this as z. So let me write z to the power q. Okay. So where z is this vector, right? So what is the qth norm of z? Do you agree? This is equal to zi to the power q, I equal to 1 to n to the power 1 by q. Yes or no?
Yes.
Then what is zi? I have told. See, zi what I have defined as zi's will be xi plus yi to the power p minus 1. Yes or no?
Yes, sir.
Good. 1 by q. Correct? Now,
Yes.
now 1 by p plus 1 by q is equal to 1 or not? If it is equal to 1, what can I say? Can I say pq is equal to p plus q? And also I can say p minus 1 into q is equal to p, right?
Yes.
So this is equal to p. So now what will I do? Do some back calculation and tell that this is equal to p to the power p minus 1 mod p. I expect people who have done all my linear algebra classes to able to tell it. What will I do? I have to make it a p norm, right? I only have a q downstairs. How will I make it a p norm? Array?
So we can just substitute it.
Yeah. We can do something like this, multiply and divide by 1 minus p. Or p minus 1, yes or no? And this will be equal to p, correct? So what do you have?
Yes.
You have I equal to 1 to n. This is what you meant by substituting it, right?
Oh, yes.
Correct? So this is your x plus yi power p minus 1, hence proved. So we have shown that p is a valid norm. This is a very, very important proof for p greater than 1. And the dual of p is q. All these things we have shown in a complete circle. Everything is done. All the missing links is over now. Can you find out any missing link anymore? I don't think so. So, but why do you still have a question that y has to be p greater than 1 in order to this to hold? I have that question. So P has to be greater than 1.
Because we won't be able to divide it.
No, for a convex function. The convex function is the first assumption that we took to find Holder's inequality, and we used Holder's inequality to prove the Minkowski inequality, right? To
Okay,
show
sir,
that
can you just once again summarize the proof?
which proof, all the proofs, right? So first thing we
this
did.
particular proof. This particular.
So first, up to this you understood?
Yes.
I think I told it once already. And then I just converted the qth norm of z. I replaced zi with xi plus yi, which as I had initially written, and then just did some algebra. And so I want to give you an entire picture. So first we use the Jensen's inequality after we introduce all the convex functions. Then what did we do? Using the Jensen's inequality, we came to the Holder's inequality. Holder's inequality we use to show the pth norm is a valid norm. So for a norm, it has to be a convex function, right? That is the basic assumption it has to hold. So for a convex function, what will happen? Because convex functions will hold the triangle inequality, as we have seen before. Consider x to be, say, 2, 0, 0, dot, 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 0, and y to be 0, 0, 0, 2, right? Okay. I'm taking just a special case. So what do you say about x plus y? Here, p and norm, pth norm. Pi triangle inequality, this has to be less than equal to the pth norm of and qth norm of y. Yes or no? Pth norm of y. Just now we showed Minkowski. So x plus y, do you agree, is 2, 0, 0, 0, 2? This it are p and norm. Is this is less than equal to 2 to the power p into 1 by p plus 2 to the power p to the power 1 by p. Correct?
Yes, sir.
These two are very simple, right? 2 to the power p e to the power 1 by p is the norm of this. 2 to the power p to the power 1 by p is the norm of this. So if you have understood what is the norm of this, 2 to the power p plus 2 to the power p to the power 1 by p, right? 2 plus 2. So you have 2 into 2 to the power p 1 by p less than equal to 4. Or you have 2 to the power 1 by p into 2 less than equal to 2. Or 2 cancel. 4. 2 to the power 1 by p is less than equal to 2. Take log 2 on both sides. What do you have? 1 by p less than equal to 1, p greater than equal to 1. Do you agree? Similarly, you can do it for any x. It's true for this. It should be true for, without loss of generality, you take any sum and do it. This is not a valid proof, but just the intuition of why, for what values this will be a convex function. For valid proof, you have to do it for any xi and yi and then expand using to the power p's and so. Is it okay? Did you understand what did I do? So your x plus y, just for your, is 20002. I have already written it though. Is it okay? Very good. So we have, with this, we have come to the very end of the class today. It will take 15 more minutes and we'll be done. So as the end goal of this optimization was to learn constraint optimization problems. So, or optimization in multiple variables. So can you tell me, do you agree that z equal to x1 square plus x2 square is a convex function, as we have shown that it is a bowl like this? Yes or no? Right? No problem with this?
Yes, sir.
So can you tell me what is the minimum of z? Zero, right?
Will be 0.
Yes.
at x1 equal to x2 equal to 0. But most of like important problems there may be like SVMs, support vector machines. There will be constraints that will be put on the optimization problem. So since there will be constraints that will be put on the optimization problem, what will actually happen? You will not be able to do. So this may not itself be in the solution set. Do you agree? So you can say that I want only a minimum in this space where this cuts this curve, right? So this may become tricky. So there's an example that I've shown over here. Say minimize x squared plus y squared subject to x1, x2 equal to 2. Right? So this is a constraint that you have. So the problem comes like this. I mean, this is your minimize f of x comma y and other variables if you have subject to some g of x, x1, x2, g of x1, x2 dot 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 xn equal to some constant c, right? In case you don't understand, tell me. But now you tell me, do you agree that if how will the contours be for these two functions? One will be a fixed function, right? x1, x2. How does x1, x2 equal to 2 look like? x1, x2 equal to 2. It's a
Hyperbola, rectangular.
very good rectangular hyperbola, right? Now I have another equation. I will draw the contours for that. How does this look? Babu, how does this look? This look like
Circle.
circles. Not one circle, many circles, right? Contours. It will be a contour.
Yes.
Right?
Yes, sir.
Now you will have to tell me. What will you have to tell me is what is the minimum value of this curve? Right? This is increasing this way. Do you agree?
Hmm.
Where will it have the minimum value? Can you tell me? Just by looking at the contours.
It is being
So
tangent to the rectangular hyperbola.
exactly. See, these are only the solution space. Do you agree? These points where they're cutting, you can only choose from these points or not.
Yes, yes, yes.
I have said because xy equal to 2, you can only choose from points on the hyperbola, right?
Hmm.
You can only choose from points on the hyperbola. But there is just one point, right, on the hyperbola that can minimize it. Other points are away, right? It will slowly come closer and finally become a tangent to the curve. Do you agree?
Yes, sir.
So do you agree that the gradient will become parallel?
Hmm.
The gradient of your f or the z will become, here f I've written, will become parallel to gradient of g, correct?
Yes.
So let's define the gradient and solve this question, and I'll give you a general way to solve it and then we'll stop. So it's very important. In your fourth year, you will have SVMs and all. Then you will see what a cakewalk it becomes when using these Lagrangian operations. So your gradient of f will be some lambda times gradient of g, right? Because they are parallel, these two vectors. Very good. Since they are parallel, they have to be, and this is called a Lagrangian multiplier. What is it called? It's called a Lagrangian multiplier. So this started off here, starting to form, minimize inequalities in this space, but slowly you will see we're moving up to convex optimizations as well. There also you'll have Lagrangian multipliers like SVM, which you can read once. I'll give you the enough theory. You can easily read SVMs. I will show you the SVM maybe if I have time. 11:15 I'll stop. Before that, if I have time, I'll just show you the intuition of SVMs, and then you can see derive the equations, because I will give you the enough mathematical framework. Yeah. So what is gradient of f? Can you tell me? Gradient of f. Let us write this as f of x and x2. What is gradient of f? This also you can write, no problem. Can you tell me? What is gradient of f? What happened? I showed you in the beginning of the class only. This is the partial derivative with respect to x1 and partial derivative with respect to x2. Yes or no? 2x1, 2x2. Gradient of g?
Yes, yes.
Gradient-
2x1
Yeah, gradient of g will be
minus 2 by x1 and minus 2 by x2.
what are you saying? Gradient of g is gradient of derivative with respect to derivative. I expect you all to be doing it in 1 second. x1, x2 minus 2, right? What is it? Just x2.
Sorry, sir.
2 is a constant. So this will be x2. And this will be x1.
Yes.
So you will have two equations or not? 2x1 is equal to lambda x2 and 2x2 is equal to lambda x1. Agreed?
Yes, sir.
So you will get lambda is equal to 2x1 by x2. Now I'll be putting lambda over here. So you'll get 2x2 equal to lambda times. What will I put? 2x1 by x2. Agreed?
x1 times 2x1 by x2.
X1 times. Good. So what will it be? 2x squared equal to lambda times 2x1 square, right? Just check the calculation once.
Lambda won't be there.
This equation I'm putting it here. 2x2. This is equal to lambda times 2x1 by x2, right? I've put lambda. Or I could have I could have substituted lambda also. Let me just substitute lambda, then it will be easier. x2 is equal to 2 by lambda, right?
Achha.
No, that I can't do. So lambda will be substituted. Sorry, this was the mistake I was making. I was not substituting lambda properly. Okay. Is this okay? Lambda is this. X1 is here. Yes or no?
Yes.
So I will have 2x2 square is equal to 2x1 square. Agreed?
X equal to x1.
Yeah. So I will have x2 is equal to x1, or mod of x2 equal to mod of x1. Correct. Very good. Then what can I do? I can find out x1 and x2 nicely. I will put mod, I will put say x1 and x2 to be both positive. So lambda will be equal to 2, right? Lambda equal to 2. And if I put x2 is equal to minus x1, that also I can do.
Lambda will be minus 1.
Minus, correct. Very good. So lambda is equal to plus minus 2. And you have x1 is equal to x2. Very good. Now, from here, I say x1, x2 is equal to 2. right? So you will have x1 squared is equal to, so you cannot have lambda equal to -2, you see, because you cannot have -2 as x square, right? X1 will be plus minus √2. Is it okay? So x1 cannot be minus x2, because if it is equal to minus x2, then you will have my x1 equal to 2, right? Or x1 squared would be equal to -2. This is not a solution because complex numbers are not here in this question. So x1 equal to, so this point is, do you agree? Where it meets is 2 comma -2, right? Or -2 comma -2 and 2 comma 2, right? √2 comma √2, √2 minus √2 comma minus √2. That's the point, is where you are getting the answer, right? So what is the minimum value? √2 square plus √2 square is equal to 4, right? Understood, everyone? Saptarshi, understood?
Yes.
So why? So you will not get x equal to minus x1 equal to minus x2. This is not a solution. Not a solution. Only x1 equal to x2 is a solution. Only. Good. So last question today will be on generalizing this operation called a Lagrangian. So you see this, whatever I have done, can I also write a term like this? This is called a Lagrangian. Lagrangian will be x1 x2 comma lambda is equal to x1 squared plus x2 squared, and you will be adding the constraint with a lambda parameter and then minimize with respect to x comma lambda. Okay. What we'll do, we will see. You can write this way. We will be minimizing with respect to x1, x2 and maximizing with respect to lambda. We'll see why. So why is this true? Do you see, if I take the gradient of this, what will I get? Gradient of f plus lambda times gradient of g, right? This is your f function, right or wrong? And this is your gradient g function, right? If it's not clear, tell me. I have written, so you can write your Lagrangian, I'm saying, in terms of f plus lambda g. Okay, where g is equal to 0. Is it okay?
Yes.
So if I take the gradient and set it to 0, that is the position I should be getting the minima at. Yes or no? And am I getting f is equal to
Yes.
minus lambda g, which is also parallel or not? Which is the same thing that I saw from the picture. Yes or no? So Lagrange put a way to, instead of using pictures and doing it manually, he put it into a single optimization problem. So that become a very high help. Why? You will see now. So if you have a more general equation, I will not do the entire math. I will show you why it is very essential, and I will do a specific question which will give you the entire understanding. So if you say you have a convex function over a vector, right? You have many independent variables and you have many constraints, h1 less than x and L1 equal to x. These are called the inequality constraints, and these are the equality constraints. Okay. So what will your Lagrangian be from what we have discussed? To satisfy all the constraints, what will I do? Tell me. What did I do? I did f plus lambda g plus lambda 2g, like this I will do, right? This will be my new Lagrangian. Correct?
It is for more than one constraint.
Which one? Tell me. Yes. Now I want
Yes, G and
interaction.
G2.
G1, G2. Yes, you will
These are
have
like all
these are,
constants, right?
no, these are constraints, not constants.
Yes, I said constant only.
Constraints. So here for this question is HIs and LIs, right? If you have HIs and LIs, equality and inequality constraints, this becomes a convex optimization problem because it's less than is a convex and so on. So do you agree I can write the Lagrangian this way in the same spirit? Fx plus the summation of all the constraints, yes or no?
Yes.
Dot lambda and gn. That's what I've written. Now this whatever it is will be equal to 0 or not. When I find the solution for a valid solution, this has to be equal to 0. Do you agree? Because by definition the constraint says that Lix is equal to 0, right?
Yes.
At a valid solution this has to be 0 and this has to be less than 0. Do you agree? At valid solution, correct? From this?
Yes.
Very good. So do you agree your f function is greater than the Lagrangian function? Because you are going to add a plus b to get L, where L is a negative, is less than 0, right? Yes or no? So the right hand side, this f of x has to be greater than the left hand side. Yes or no? Because left hand side is a subtracted version of the f of x. This has to be valid. Now what will I do? What is my objective? Is to minimize x, right? That is my objective. I want to minimize x, right? Minimize, find argmin of x, yes or no? That is. So do you agree if I argmin this, if I do min over x, that will be even lesser, yes or no? Correct? Referred to, so let me write ai module ui and vi's. That will be easier to understand. Because since I'm writing u and v, is this okay? Since minima, I'm minimizing it, it will always be lesser than the Lagrangian. I'm minimizing Lagrangian. Okay. So when I'm minimizing this, do you see x will move out? X will be disappearing because I'm minimizing over x. It will become a constant, right? If you have a function over x, if I minimize it, I'll get a constant or not?
Yes.
So you'll marginalize over x. So you will get a function that is you define as the dual function of u and v. So do you agree your f star, whatever you have, will be greater than u and v? Do you agree? Now you can maximize u and v also, yes or no? Because the right hand side only depends on x and left hand side only depends on x. Right hand side does not depend on y. Again y, x, right? Yes or no? Right hand side does not depend on x, right?
Yes.
So I can maximize. So this will be sort of the maximum upper bound or not? Or maximum lower bound for f. So for some nicely behaved functions where Slater's condition hold, that is for at least one x1, it should be strictly less than. So all the inequalities must be strictly less than 0 for all I. Then what happens is the max of uv, g of uv is equal to f star x, or max of uv mean over x Lagrangian of uvx is equal to minimum of x f of x. Did you understand? In that condition, if this is your max over g, and your min over f, they are the same value, like this. Is the figure and the understanding clear? Right? In other cases, the lesser than will hold. Only in the case like SVMs and all, the equality will hold because Slater's condition is true. Is it okay? Did you understand? I can take
Yes.
a max over this. So your objective function becomes something like this. Correct? This is always going to be true, and this is true only when Slater's condition holds. So let's finish today's discussion by doing, please, if you are interested, read the SVMs. It's a wonderful, so let me give you a brief introduction of what SVMs are. So if you have some positive points, I'll tell positive points, and this some as negative points. Right? So SVM normal regression would do something like this, but SVM what it does, it maximizes the there's a road, it builds a road between the positive and negative point so that there is a good separability. Right? This is what SVMs do. So what does it do? It does something like this: W transpose X plus B is greater than 1 and W transpose X plus B is less than 1 for Y positive, for Y negative. So these will become constraints and it will try to minimize the weight of the classifier. Why will it try to do that? You can check it out. It will try to minimize. So you can think of it as a regularized version where W is going to be a as minimum norm is possible, you will do, and these will be your constraints. So in this case, it is not possible to solve the primal solution, but the dual solution you can solve easily. So this is why the Lagrangian is very useful. So I've given you the understanding. Please go ahead and read it. -1. So that this question will do, and we'll call it a day, and that will complete all the maths in our course. Last day will be just a program on what is called as gradient descent, and we will be stopping tomorrow. So it was a very nice teaching you all. Thank you for your interest. So we are not done yet. You have to submit your assignments. Remember that I have not found a single solution of any assignment yet. Right? So you are saying GY you have to minimize, which are WIs by YIs, such that the sum of YIs equal to 1 and YI greater than 0. This is also known as a unit simplex. Because do you see yi plus y2, if y1 plus y2 is equal to 1, right? And y1 greater than y2, y1 comma y2 greater than 0. This is this line, right? Yes or no? So if it is less than 1, then it is a unit simplex, or it is just this line on which we want to optimize, right? It's a very, very popular problem because do you see this is also like a probability or not? Probability, PMF? Yes or no?
Yes.
So this is a clustering algorithm. I'm teaching you the mathematics of the algorithm. If I get a chance of teaching you maths machine learning itself, I'll be teaching. That time I'll be just teaching the intuition of using it. But today I'll be just showing you if this algorithm is there, how will I use? What will be the PMF of y's, right? Is it okay? So I want to find y's, right? This is the g function, right? G is a function of y or not? Y is a vector. y1 dot 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 yn. Yes or no? Do you agree? Good. So I want to optimize over g of y. It's a constant optimization, multidimensional optimization problem, yes or no? Good. So what will be my first step? Lagrangian, right? Y comma v. So what should be the Lagrangian operation here? Tell me. G of y plus lambda times 1 minus, for now, consider y belongs to real. So this is the trick solving this question. You will see that y automatically becomes greater than 0. Try to use this trick anywhere. Try to optimize over reals and then see if it is not happening, then you will have to do projected. Here you don't need projected anything. Projections and all. Is the Lagrangian clear? Array, g of y plus the constant. This is the constant or not? 1 minus I equal to 1 to n, yi equal to 0. This is the constant. Others, is it? Now what will I do? I will take first step. What did I do? Minimize over y, yes or no? Correct? Good. If you have understood, it's trivial, I think. Wi square by yi square. So what will be your d Lagrangian dyi? What will it be? What will it be? The derivative with respect to the ith component, what will it be? It's very simple. Sum of independent sums. W1 square by y1 square plus W2 square plus y2 square and so on. Tell me. Oh, my y2 square nahi ekhane. Shudhu y1 ache. Question that. So what will it be? Minus yi square by wi square by yy square, right? Minus yi dy. Yes or no? Other terms are all 0, right? Dyj by dyi I not equal to j is 0. By the property of partial derivatives. Now what will I get? I will get lambda is equal to yes or no? Good. So we can do this only, no problem. So I'll get lambda is equal to this. Very good. So next, what should I do? Next step, what should I do? So do you see your wi or your yi, right? Should be equal to wi square by root over of minus lambda. Yes or no? Correct? So lambda has to be less than 0 in our case.
Yes.
Very good. So I can make this to be, say, minus lambda is equal to some k. So yi I will make as good. So now I have to find k's, right? So what is the constant now? Do you see this is positive? So my constant yi has to be greater than 0 is satisfied. So one more constant has to be satisfied. What? Which is the one? Wi is equal to 1, right? So what will I have? Summation of mod wi I equal to 1 to n by 1 by k root over is equal to 1, or root k is equal to summation of I equal to 1 to n wi, right? So what will this turn out to be? Yi will be wi proportional to wi by summation of wi I equal to 1 to n. Is it clear with everyone? In this case, we didn't even need a maximization because there was no less than constraint. You got a valid solution instantly. Is it clear, everyone? How did I use the Lagrangian operation? Because okay. So with that, we come to end of the foundations of app optimizations as such. We will do gradient descent next day. Very short lecture, 1.5 hours class we'll have. And I have prepared your question for the coding assignment as well. I'll also give you a short tutorial on Python, just in case you do not already know. I'll show you how to code linear regression and logistic regression, and I'll share the files with you so that you can code it yourself. So let me stop recording and then I'll take questions if anyone has any.